Hello, we are in Chapter 7, Section 7.3, Exponential Functions. In this video, we're going to go over problem number 7, in which we are to graph this transformed exponential function by first filling in the table and then recognize the properties of our function. Recall that the negative in front of something means simply the factor of -1. So it's really the same as -1 multiplied by 2 to the power of x. So if for any input we first identify what's 2 to the power of x, then we can simply multiply that number by -1, or simply take the opposite of it, and that will give us the results that we're looking for in here. So we'll be plugging in for x. For example, if we use x equals 0, it will be 2 to the power of 0, which is 1, but then multiplied by that -1, resulting in -1, giving us the first point on the graph, 0, -1. Now let's move on to those positive exponents on 2. 2 to the power of 1 is 2, 2 to the power of 2 is 4, and 2 to the power of 3 is 8. But then we take the opposites, because we're multiplying those numbers by -1. So we're gonna get -2, -4, and -8 actually, resulting in another 3 points. 1, -2, 2, -4, and 3, -8 on the graph. Then moving to the negative exponents, we start with -1. 2 to the power of -1 is simply the reciprocal of 2, which is 1/2. We multiply that by -1 or take the opposite to obtain -1/2 as the final result, giving us the point -1, -1/2. And raising 2 to the power of -2 is really reciprocating 2 squared, and 2 squared is 4, so we get 1/4. That we multiply by -1 to obtain -1/4, resulting in the point -2, -1/4 on the graph. And finally, 2 to the power of -3 is the reciprocal of 2 to the power of 3, which is 8, so it's 1/8. And we multiply that by -1 to obtain -1/8 as the value, resulting in another point on the graph, -3, -1/8. Now that we have enough points on the graph, let's join them with a nice smooth curve that extends in both directions and identify the properties of our function. The domain, as for every simple exponential function, will be all real numbers from -infinity to infinity, since we don't have any constraints for the domain. The range is identified vertically, and it looks like this time we are going from -infinity up to the level of 0, the level of x-axis in other words, because it looks like our graph is tending toward that, never reaching it. So we go this time from -infinity up to 0, never reaching it, so open interval. And the horizontal asymptote is the line over or under which the graph is hovering, and here it's really upside down, but that line is here the x-axis, whose equation is y equals 0.